The half-life of sodium-24 is approximately 15 hours. An intern spends a day in a laboratory taking hourly measurements of the amount of sodium-24 to the nearest gram in a 250-gram sample and recording the data in a table. Use average rates of change to generate a function model. Then determine the accuracy of the function model by comparing the function values to data values associated with 1, 3, and 6 hours. Okay, so let's first find our function models. And so we need to take the average rate of change, and so we'll do that by just taking our dependent, which is a of t. We'll take the last minus first values there and divide by the last minus first independent values. And so that gives us, in the numerator, that subtracts to negative 77, and then divided by 8, and so then we get negative 9 and 625 thousandths using a calculator. And so that will be our rate in our function, so we'll have a of t equals negative 9 and 625 thousandths t, and then plus the y-intercept, which in this case, when t is 0, then a of t is 250, so that would just be 250. And so now we want to compare our function model with the actual values in the table with 1, 3, and 6 hours. And so let's go ahead and plug in 1. So a of 1, typing that into a calculator, then we get 240 and 375 thousandths. And we're going to be comparing that, at 1 in our table, then that's compared to 238. And so let's go ahead and find the percent of error there. And so we would just take what we got from our function model and subtract the original value and then divide by that value, 238. Typing this in the calculator, making sure to put the numerator in parentheses, then we get 0, 0.0099, and so on. And so it's a pretty long decimal. Let's just go ahead and round it up there to the nearest thousandth. So that 9 would round up this 9 to a 10, so that would bump that into our hundredth spot. So we'd have 0.01 or 1/100ths. We round it there, and then that's a decimal form. Let's turn that into a percent by moving that decimal over to the right twice. And so that would be an error of about 1%. So that is really close. That's a very good model with just an error of 1%. Let's go ahead and plug in 3. So this gives us 221 and 125 thousandth grams. And we're going to be comparing this to a of 3 in our table, which is 217. And so then again, doing the same thing to find the percentage of error, we'll go ahead and subtract our value in the table from the value got in the function and then divide. So then doing that, and that gives us 0.01900, etc. And so again, rounding that to the nearest thousand, that would just be, 0.019. And as a decimal, moving the decimal place over twice, that would just be 1 and 9/10%. So again, not a very large error. So lastly, let's go ahead and plug in 6. So here you get 192 and 25/100ths grams, and we're comparing that to, in our table, 189. So let's go ahead and plug that into our form for the percentage of error. And so there we get 0.017195, etc. And so let's go ahead and round it to the nearest thousandths. So we would just round that to 17 thousandths. And then as a percentage, that would just be 1 and 7/10%. So the percentage in each case is fairly small, so our model is fairly accurate. Let's go ahead and summarize. Using the average rate of change, a of t equals negative 9 and 625 thousandths t plus 250. a of 1 equals negative 9 and 625 thousandths times 1 plus 250 equals negative 9 and 625 thousandths plus 250 equals 240 and 375 thousandths grams. The actual value from the table is 238 grams. The percent error of the prediction is approximately 1%. a of 3 equals negative 9 and 625 thousandths times 3 plus 250 equals negative 28 and 875 thousandths plus 250 equals 221 and 125 thousandths grams. The actual value from the table is 217 grams. The percent error of the prediction is approximately 1 and 9/10%. a of 6 equals negative 9 and 625 thousandths times 6 plus 250 equals negative 57 and 75 hundredths plus 250 equals 192 and 25/100ths grams. The actual value from the table is 189 grams. The percent error of the prediction is approximately 1 and 7/10%. The function model generated by average rate of change approximates the data in the table fairly accurately since the percent error is small in each case.